Hello, Accelerated Chemistry students. This is Mr. Spurk, and this is your Chapter 14, Section 1 notes, all over the properties of gases. So compressibility is the first one we're going to talk about. Gases are easily compressed, or they're squeezed into a smaller volume. Compressibility is a measure of how much the volume of a matter decreases under pressure. Because gases can be compressed, the airbag absorbs some of the energy from the impact from a collision. Gases are easily compressed because of the space between particles in a gas. The volume of the particles in a gas is so small compared to the overall volume of the gas. The distance between the particles in a gas is much greater than the distance between particles in a liquid or a solid. Under increased pressure, the particles in a gas are forced closer together. So if we look at these two containers, the one on the left, in the larger container, the molecules are farther apart, but in the smaller container, the air sample is compressed and the molecules have to be closer together. So there's some factors affecting gas pressure. The four variables generally used to describe a gas, and their common units are the number of moles, which we use as lowercase n, volume is in liters, which is a capital V, temperature, capital T, which we will use kelvins, and pressure, capital P, in kilopascals. The amount of gas, volume, and temperature are factors that affect gas pressure. So the amount of a gas. You can use kinetic theory to predict and explain how gases will respond to changes of conditions. If you inflate an air raft, for example, the pressure inside the raft will increase. There will be collisions of gas particles with the inside walls of the raft, results in the pressure that's exerted by the enclosed gas. Increasing the number of particles increases the number of collisions, which explains why the gas pressure increases. So you have these things in a confined space, and they're just bouncing all around. They're pushing out on the edges of their container. That's the pressure. When a gas is pumped into a closed, rigid container, the pressure increases as more particles are added. If the number of particles is doubled, the pressure will be doubled. Once the pressure exceeds the strength of the container, it's going to end up bursting. So we can see from left to right, we are adding more particles, which means we're increasing the pressure, and then eventually the container can't hold the pressure anymore and it busts open. So now we're on to pressure. If the pressure of the gas in a sealed container is lower than the outside air pressure, air will rush into the container when the container is opened. When the pressure of a gas is in a sealed container higher than the outside pressure, the gas will flow out of the container when the container is unsealed. Think about when you open up a bottle of pop or a can of pop. When you open it, the pressure inside the can or the bottle is a lot higher than the air pressure outside, which is why we hear that gas running out or escaping from that can as quickly as it can. So now we're going to talk about volume. You can raise the pressure exerted by a contained gas by reducing its volume. The more the gas is compressed, the more pressure the gas exerts inside the container. Increasing the volume of the contained gas has the opposite effect. If the volume is doubled, so it's increased, the particles can expand into a volume that is twice the original volume. With the same number of particles and twice the volume, the pressure of the gas is cut in half. A piston can be used to force a gas cylinder into a smaller volume. When the volume is increased, the pressure of the gas exerts is decreased. And then on the right side, we have when the volume is decreased, the pressure of the gas exerts is increased. So now we're on to temperature. You can use kinetic theory to explain what happens as a gas is heated. The temperature increases and the average kinetic energy of the particles in the gas increases. Faster moving particles strike the walls of the container with more energy. An increase in temperature causes an increase in pressure of an enclosed gas. The container can explode if there is too great an increase in the gas pressure. All right, so in review, gases are easily compressed because of the space between particles in the gas. The amount of gas, N, volume, V, and temperature, T, are factors that all affect gas pressure. As always, all the information on these slides has been acquired and adapted from PearsonChemistry.com, 2012 edition of the textbook, and the resources CD. Have a good day, guys.